Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session October-November 2021 Paper 2-2. So let's start with the first question. Question number 1. The polynomial p of x is defined by, we have p of x in terms of a and b, where a and b are constants. It is given that x plus 2 is a factor of p of x. So x plus 2 is a factor of p of x. It means p of minus 2 should be equals to 0, and that the remainder is negative 55 when p of x is divided by x plus 3. This means that p of negative 3 is equals to minus 55. Part A, find the values of A and B. Now using these two information, we can easily find the values of A and B. P of minus 2 is equals to 0, right? Okay, so x is minus 2, so A minus 2 cube plus b times minus 2 minus 10 equals to 0. So this is negative 8a, negative 2b, negative 10 equals to 0. Let me divide by minus 2. So 2 times 4 is 8, 2 times 1 is 2, 2 times 5 is 10 equals to 0. From here we have the b value, which is minus 4a and minus 5. This is my first equation. Right. Now using the second information, p of minus 3 is negative 55. P of minus 3 is negative of 55. All right. So we have a minus 3 cube plus b times minus 3 minus 10 equals to minus 55. Okay, let me simplify. Minus 3 cube is negative 27. Let me double check. Negative 27a minus 3b minus 10 plus 55 equals to 0, right? So we have 55 minus 10 is 45. So minus 27a minus 3b plus 45 equals to 0, right? Or minus 27a minus 3, the b value is minus 4a minus 5 plus 45. This is equals to 0, right? Okay, now we have we can easily find the a value. Minus 27a minus minus plus 3 times 4 is 12a, minus minus plus 3 times 5 is 15 plus 45 equals to 0, right? Now we have 12 minus 27 minus 15a, and 15 plus 45 is 60 plus 60 equals to 0. So negative of 15a equals to negative of 60, and minus 60 divides minus 15 is 4. So the a value is 4. Now substitute that a value into the first equation. We can get the b. So b is minus 4 times 4 minus 5. So minus 4 times 4 subtract 5. This is negative of 21. So the b value is minus 21. All right. So from here we can say a is 4 and b is negative of 21. Let me write down the polynomial now. So p of x is a x cube plus bx minus 10. This is the polynomial. Now for part B, hence factorize p of x completely. So we have given p of x, which is 4x cube minus 21x minus 10. And we have given the information that x plus 2 is the factor. So if I use the synthetic division method here, all right. So we have the coefficient of x cube is 4, coefficient of x square is 0, coefficient of x is minus 21, and constant term is negative 10. Minus 2 is the factor, so we need to bring 4 down. 2 times 4 is 8, minus 8. When we add, we have negative 8. Negative times negative is positive. 2 times 8 is 16. And minus 21 plus 16, sorry, minus 21 plus 16 is minus 5. Negative times negative is positive. 2 times 5 is 10. And when we add, we have 0. Now, p of x is x plus 2 into we have a quadratic now, 4x square minus 8x minus 5, right? Okay, applying the quadratic formula, or we can just factorize this quadratic equation. So we can say 4 times 5 is 20, 2 times 10 is 20, and we have 2 minus 10 is negative 8. X plus 2, 4x square plus 2x minus 10x minus 5. Okay, x plus 2, we are left with, let me take 2x common. So 2x plus 1, and negative 5 is common, 2x plus 1. Okay, so the factors are x plus 2, 2x plus 1, and 2x minus 5. So this is a complete factorized form of the polynomial p of x. Question number 2, part A. Sketch on the same diagram the graph of y equals to x plus 3 and y equals to absolute of x plus 2. Okay, 2x minus 1. Okay, so let me use the first function. We have a linear function y equals to x plus 3. Let me find the x and the y intercept. When x is equals to 0, the y is equals to 3, and when y equals to 0, x is equals to negative of 3. Right, now considering the second function without absolute, we have y equals to 2x minus 1, finding the x and y intercept. So when x is equals to 0, y value is negative. So the x-intercept when x is 0, y is negative 1. So absolute of negative 1 is 1. And when y value is 0, the x is 1 by 2. Right? Now let me sketch the graph. Let me make the grid first. This is absolute, so it should be in first and second quadrant. Yes. Okay. Okay, let me select the scale now, because we have x and y intercept we have given, which are 0, 3 and 0, minus 3, and they are 0, 1 and 0, 1 by 2. Okay, max is 3 in centimeters. If I can do here, this is 1, 2, 3, 4, 1, 2, 3, 4, and over here 1, 2, 3, 4. Right, so the let me sketch y equals to x plus 3, the straight line. So the x-intercept when x value is 0, y value is 3, and when y equals to 0, x value is negative 3. X is negative 3 and y is 3 here. Right, let me connect the points to get the straight line. Okay, now the second one, when x is 0, y is equals to 1, this point. Okay, and when y is 0, x is 0.1. So this is 0.1, right? Let me take another point. It's a v-shaped graph for the absolute value function. Okay, so if I can take a point x is equals to 2, let me take it, x is equals to 2, y is equals to absolute of 4 minus 1. 2 times 2 is 4, so y value is 3. 1 into x is 2 here, and y is 3 at the top. So this point, yes. Let me connect this. Okay. Now for part B, solve the equation x plus 2 is equals to absolute of 2x minus 1, right? So there are two ways we can scaling on both sides, or we can say x plus 3 is equals to plus 2x minus 1, or x plus 3 is equals to minus of 2x minus 1. This is x plus 3 equals to 2x minus 1, x minus 2x equals to minus 1, minus 3, minus x equals to minus 4, so x value is equals to 4, right? This is your x-intercept, right? So this, sorry, not the x-intercept, we have the point of intersection, right? So as you can see, if I extend this line and this v-shaped graph, it will meet at x is equals to 4, this point at 4, right? Okay, the second intersecting point is x plus 3 is equals to minus 2x plus 1, x plus 2x, this would be 1 minus 3, this is 3x equals to minus 2, and x is equals to minus 2 by 3. So this is x equals to minus 2 by 3. So there are 2 points of intersection, right? Now for part C, find the value of y such that 5 power 1 by 2y plus 3 equals to 2 times 5 power 1 by 2y minus 1 absolute. Give your answer correct to 3 significant figures. So as you can see from part B, we have an equation x plus 3 is equals to absolute of 2x minus 1. So plus 3, 2x minus 1 and absolute. So here we can say x is equals to 5 power y by 2 basically, right? And we have two solutions for x. So we have the x value. So from here we can say 5 power y by 2 is equals to 4, or 5 power y by 2 is equals to minus 2 by 3. Right, so we have to find up to 3 significant figures, the value of y. So taking ln on both sides, so we can say y over 2 ln 5 equals to, or log 5 log of 4. No need to take ln, taking log, sorry. Okay, and what is y? Y equals to log 4 divides log 5, and this is times by 2, multiplying by 2, right? Let me calculate this. Log 4 divides log 5 times by 2 is 1.7227, and up to 3 significant figures 1.72. Y value is 1.72, right? Now for the other one, from here y is equals to log of negative 2 by 3 divides log 5 times by 2. This is undefined because log of negative number does not exist. We can take log minus 2 by 3. This is undefined, right? Okay. Question number 3, the curve with equation y equals to this has exactly one stationary point in the interval 0 to pi by 4. Find the coordinates of this stationary point, giving each coordinate correct to 3 significant figures. It has exactly one stationary point. So for stationary point, what we have to do? For stationary point, we have to say dy over dx should be equals to 0, right? So let me calculate dy by dx. So this is 5 and x derivative is 1 minus 2. The derivative of tan x is secant square x. So here we have secant square 2x and derivative of 2x is 2 equals to 0. 5 minus 4 secant square 2x equals to 0, right? Now we can say 4 secant square 2x equals to 5, right? And secant square 2x is equals to 5 by 4. And what is secant square? Secant square is 1 over cos square 2x, right? So we can find the value of cos. So cos square of 2x is the reciprocal 4 over 5. And cos of 2x is equals to 2 over square root of 5 with a plus minus sign, right? Plus minus square root of 4 by 5 is 2 by square root of 5, right? Okay, now we have two values for cos. From here we can say cos 2x is 2 by 5 square root of 5, or cos 2x is negative 2 over square root of 5, right? Now let me find the x value. So here we can say 2x is cos inverse of 2 by square root of 5. The range for x we have given is between 0 to pi by 4. It is in radians. My calculator is in radians, yes. Okay, cos inverse 2 divide square root of 5, which is 0.46, and you have to divide this by 2, which is 0.2318, up to 3 significant figures. So x value is it should be between 0 to pi by 4, right? It basically it is first quadrant, it lies 0 to pi by 4. So we are just dealing with the first one. So the x is equals to 0.23232 up to 3 significant figures, right? Let me calculate the other one. 2x is cos inverse of 2 over square root of 5. We have to do the positive one, and then we can check cos is negative in which quadrant. So cos is negative in second and third quadrant, right? Okay, so cos inverse 2 divides square root of 5 is this, right? So we can say 2x is equals to 0.46364, and if it is negative in second quadrant, and for second quadrant, what we have to do, we need to do 180 pi minus that answer. Yes, pi minus answer, and then divide it by 2. This is 1.33, which is not in the given range, 0 to pi by 4. Now let me check for the third quadrant as well. So for third quadrant, we do pi plus 0.46364 divided by 2. Again, it is 1.80, it is more. So this does not belongs to the given domain between 0 to pi by 4. So this belongs to the domain. We have x. Now let me find the y. The y value is 5 times 0.232 minus 210, 2 times 0.232. All right. Let me calculate this. 5 times 0.232, which is 1.16, minus 2 times 0.232, tan of answer, times by 2 is 1.000881133. Okay, 1.16 subtract answer. This is 0.159 up to 3 significant figures. Okay, so it has only one stationary point, and the coordinates of the stationary points are up to 3 significant figures. We have 0.232, the x coordinate, and the y coordinate is 0.159. All right. Question number 4, given that the integral this should be equals to ln of 2, find the value of the positive constant a. Okay, so the integration we can do 1 over 3 is outside, 1 over x integration is ln x. So between a to a plus 14, this should be equals to ln 2. 1 over 3, the upper limit is ln of a plus 14, minus 1 over 3, the lower limit is ln of a. This is equals to ln 2, sorry. So we can say 1 over 3 is outside, ln of a plus 14 minus ln of a, this is ln 2, right? 1 by 3 is outside, ln a plus 14 divides a, this is ln 2, right? So we can multiply with 3 here. So ln of a plus 14 over 2 over a equals to 3 times of ln 2. So ln of a plus 14 over a is equals to ln of 2 power 3, which is ln 8. Right, now we can easily cancel ln on both sides. So ln and this ln, and we are just left with a plus 14 over a equals to 8. Cross multiplication, a plus 14 equals to 8a. So 14 is equals to 8a minus a. 14 is equals to 7a. Dividing by 7 on both sides. So a value is equals to 2. A is a positive constant, so its value is 2. Question number 5. A curve has equation this. Find the exact value of the gradient of the normal to the curve at the point this. Okay, so we have to find the gradient of the normal to the curve at this point. All right, so the first thing is we have to find the gradient of tangent, dy over dx, right? So d by dx of 2x plus 4 is outside, d by dx of x cos 3y and 6 d by dx of 1. All right, okay, so this is 2, dx over dx is 1 plus 4 is outside. Applying the product rule, d by dx of first term, second term is as it is, plus we have to find d by dx of cos 3y and d by dx of x is 1, and the derivative of constant is 0, right? Okay, so we have 2 plus 4, this is cos 3y, plus the derivative of cos is minus sine 3y, and derivative of 3y is 3 dy over dx, and dx over dx is 1 equals to 0, right? So this is 2 plus 4 cos 3y minus 12 sine 3y dy over dx equals to 0. So we can say minus 12 sine 3y dy over dx, this should be equals to minus 2 minus 4 cos of 3y. Taking negative sign common or dividing by minus 12, so we have sine 3y dy over dx is equals to, we have negative 2 over negative 12 is 1 over 6, negative 6 over negative 12 is 1 over 3, plus 1 over 3 cos 3y. All right, now from here, what is dy over dx? This should be 1 over 6 sine 3y dividing by sine 3y plus 1 over 3 cos 3y over sine 3y. This is the gradient of tangent. We have to find gradient of normal. So we can say at when x is square root of 2 and y is pi over 12 at this point. Sorry, I did mistake here. The derivative of first term second function is as it is, derivative of second function first function is as it is. This is not the derivative, right? So we have x as well, 12x, this should be with x, okay, and x, so we can divide with x as well. Okay, now substituting the points, we can find dy over dx is 1 over 6 square root of 2 sine 3 pi over 12, right, plus 1 over 3 times cos 3 pi by 12 over square root of 2 sine 3 pi by 12. All right, let me calculate this. 3 pi divides 12 is pi by 4. Sine of answer is this times square root of 2 times by 6 is 1 by 6. Right, okay, and plus this is pi by 12. We have cos pi by 4. Pi by 4 divide sine pi by 4 is 1, so this term is 1, so we are just left with 1 over 3 square root of 2. Okay, so we have 1 by 6 plus 1 over 3 square root of 2. Let me keep this in terms of square root of 2. What is sine pi by 4? Square root of 2 over 2. So basically 1 over square root of 2. There is another blunder. This is x square. The derivative of x square is 2x. Yeah, I messed up this derivative. I'm sorry. And this is x. X is cancelled with x, right? Square root of 2 is cancelled with square root of 2. So this is 1 over square root of 2, right? 1 over square root of 2, right? So if we do its reciprocal, it is 2 over square root of 2. 2 times 3 is 6, right? 1 over 3 square root of 2, 1 over 3 square root of 2. 1 by 3 plus 1 by 3. This is 2 by 3 square root of 2. This is 2 over 3 square root of 2 in the denominator. All right. Okay. Now to find the gradient of normal, we have to do the negative reciprocal of gradient of tangent, right? So we have gradient of tangent is 2 over 3 square root of 2, and the gradient of normal is negative and reciprocal 3 square root of 2 over 3 over 2. Question number 6, part A. By sketching a suitable pair of graphs on the same diagram, show that the equation ln x equals to 2e power minus x has exactly one root. Let me sketch the grid first. Okay, let me select the scales. Okay. 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. And over here we have 1, 2, 3, 4, 5. 1, 2, 3, and 4. All right, let me sketch the graph of ln x first, right? So for ln x, so we have to start with positive values of x, because ln of negative numbers is undefined and ln of 0 is also undefined. Ln of 0 is infinity, so it's downward, right? So at 0 it is undefined, right? So sketching from ln 1, which is equals to 0, ln of 1 is 0, and ln 2 is 0.69, or we can say y value 0.7. At 2 it is 0.7, closer to 1. ln 3 is 1.1. ln, okay, it's closer to 1 if I can use the scale. And this is 1 over here. This point we can take, yes, this is better. ln of 3 is a point when it is 1.1, little bit above 1. And ln 4, 1.4. This is ln 4. This is 1 and in the middle of 1 and 2. And ln 5, 1.6. This is ln 5, ln 1.6. So this would be the shape of the curve, right? Let me connect the points. Alright, so this is the sketch for ln x. Okay, this is for ln x. Right, now the second one is 2e power minus x, right? So let me start with the positive values of x. Okay, so 2e power minus 0, which is 2. So the y value is 2. So this is 2. Okay, e power minus 1, which is 0.7. So 0.7, it's 2, it's 1. At 1, when x is 1, it is 0.7. This point. Okay, at 2, 0.3. At 2, it is 0.3. And at 3, it is 0.1. So closer. So this would be the shape. And let me take the negative one as well. This is 5.45. At minus 1, its value is 5. 1, 2, 3, 4, 5. Yeah, this point. Okay, let me sketch this. So this would be the shape. All right, connecting the points. Okay, so this would be the graph of 2 e power minus x, and it has exactly one root. You can see it intersect at one point. Now for part B, verify by calculation that the root lies between 1.5 and 1.6. It should lies between 1, this is 1 and this is 2, 1.5 and 1.6. So if it lies between 1.5 and 1.6, it means the sign change occur. We have equation ln x is equals to 2 e power minus x, right? At x is equals to 1.5, we can solve ln 1.5 equals to 2 e power minus 1.5, and let me calculate what is ln 1.5. This is 0.4, and we have 2 e power minus 1.5 is 0.446, 0.45, 0.45 if we round to 2 decimal place, and ln of 1.5 is 0.41. So 0.41 is less than 0.45, right? Now the other one at x is equals to 1.6. We can take ln of 1.6 equals to 2 e power minus 1.6. Okay, ln 1.6 is 0.47, 0.47, and 2 e power minus 1.6 is 0.40. 0.47 is greater than 0.40. So as you can see, sign change occur, less and greater. This implies root lies between 1.5 and 1.6. All right. Part C, show that if a sequence of values given by the iterative formula this converges, then it converges to the root of the equation in part A. Okay, so we have given ln of x equals to 2 e power minus x in part A. So taking e on both sides, so e power ln x is equals to e power 2 e minus x. E ln x is x equals to e power 2 e power minus x, and this x is replacing with xn plus 1. This is e power 2 e power minus x power n. So as you can see, if the sequence of values given by this iterative formula converges, then it converges to the root of the equation in part A. It is proved. Now for part D, use the iterative formula in part C to determine the root correct to 3 significant figures, given your result of each iteration to 5 significant figures. So we have the formula xn plus 1. This is equals to e power 2 E minus xn. Okay, and the initial guess we can say it lies between 1.5 and 1.6. We can take 1.55. All right, let me make a table for this, and up to 5 significant figures we have to calculate each iteration. Okay, this is for xn and this is for xn plus 1. Okay, now the first iteration is 1.55. All right, so when xn is 1.55, we have e power 2 e power minus 1.55 is 1.5288 up to 5 significant figures, right? 1.52888. We have 1.542, round to 8, right? 1.5428, 1.533 and 5, rounded to 5, yes, up to 5 significant figures. Now this is 1.5335, this is 1.539 and 6, round to 7, right? Okay, 1.5397, 1.5356, 1.5356 is 1.538 and 3. All right, okay, and up to so on. Let me fill this column as well. It is 1.5288. This is for, no, this is here 1.55, 1.5288. This is 1.5288, 1.428, 1.5335, 1.5397 and 1.5356. Okay, so as you can see, we have to find the root up to 3 significant figures. So it is 1.5 is fixed. Now this rounded to 3, 4, this 3, 4, 4, 4. So 1.54 is the root up to 3 significant figures, and it lies between 1.6 and 1.5 and 1.6. Question number 7, part A. Prove that this side should be equals to this. So left hand side should be equals to the right hand side. Okay, starting from left hand side, we have 4 sine x and sine x plus 1 over 6x. So open the formula of sine a plus b, which is equals to sine a sine b plus cos a cos b. All right, so if I can calculate in radians, what is sine pi over 6? Pi by 6, 1 by 2. So 4 sine x into 1 by 2 plus cos x and cos pi by 6 square root of 3 by 2. Okay, so 4 by 2 sine square x plus 4 by 2 square root of 3 sine x cos x product. Okay, 4 by 2 is 2 sine square x. We can open, so we need this in cos 2x and sine 2x. Okay, sine square x is 1 minus cos square x plus 2 square root of 3 sine x cos x. Okay, so if I open this, we have 2 minus 2 cos square x. If I subtract 1 and add 1, and we have square root of 3, 2 sine x cos x is sine 2x, right? So here we have 2 plus 1 is 3, minus is outside, 2 cos square x, and 2 cos square x. So 2 cos square x, and taking this minus 1, so 2 minus 1, this is 1, sorry, plus square root of 3 sine 2x, right? Now this is 1 minus, this is cos 2x plus square root of 3 sine 2x. So but we have given that with sine 2x the coefficient is just 1, so we can divide all the terms by square root of 3. 1 over square root of 3 minus 1 over square root of 3 cos 2x plus square root of 3 over square root of 3 sine 2x, right? So 1 over square root of 3 is basically square root of 3 minus square root of 3 cos 2x plus sine 2x. So this is proof to right hand side. Okay, now for part B, find the exact value of this integral between 0 to pi by 6, 5 pi by 6. Okay, so from 0 to 5 pi over 6, we have this integral square root of 3 minus square root of 3 cos 2x plus sine 2x with respect to dx. Okay, now let me apply the integration. This is square root of 3x minus square root of 3. The integration of cos is sine 2x divided by 2, plus the integration of sine is minus cos 2x divided by 2, and the limits are between 0 to 5 pi by 6. Okay, let me apply the limit. Square root of 3 5 pi by 6 minus square root of 3 divided by 2 sine 2 times 5 pi by 6 minus 1 by 2 cos 2 times 5 pi by 6. This is okay. This is the upper limit. Now for the lower limit, this term is 0, sine 0 is 0, cos 0 is 1, so minus 1 by 2, and lower limit would makes plus 1 by 2. All right, for the simplification, if I can do the rest of the steps here, so this should be 5 over 6 square root of 3 pi minus square root of 3 divides 2. 2 times 5 is 10, so sine 10 pi by 6 minus square root of 3 by 2 minus 1 by 2 cos 10 pi by 6 1 by 2 and positive 1 by 2. Okay, let me simplify this further. So we have 5 square root of 3 over 6 pi, and plus square root of 3 times square root of 3 is 3, 2 times 2 is 4, minus 1 by 4 plus 1 by 2. Okay, 3 by 4 minus 1 by 4 plus 1 by 2 is just 1. So the answer is 5 square root of 3 over 6 pi plus 1. This is the exact value of the integral. Now for part C, find the smallest positive value of y satisfying this equation, giving your answer in an exact form. Okay, so we have the equation 4 sine x plus pi by 6 equals to square root of 3. Let me compare with the given one. We have 4 sine x plus pi by 6. This is equals to square root of 3 minus square root of 3 cos 2x plus sine 2x. Okay, now if I replace my x value with 2y, right, sine 4 sine 2y into sine 2y plus pi by 6, this term is equals to this one. Okay, so we can say square root of 3 minus square root of 3 cos 2 times of 2y plus sine 2 times of 2y, this is equals to square root of 3, right? So here we can easily cancel square root of 3 with square root of 3, right? And we are left with minus square root of 3 cos 4y plus sine 4y equals to 0, right? So sine over cos we can make tangent, yes. So if I can divide by cos, so minus square root of 3 over here plus tan of 4y equals to 0. Sine over cos is tan, cos over cos is just 1. So we can say tan 4y is equals to positive square root of 3. We have to find the exact value of y, right? So we have 4y is equals to tangent inverse of square root of 3. Let me calculate this. Tangent inverse square root of 3. This is pi by 3. So 4y is equals to pi by 3, and dividing by 4, this is pi by 12. So the exact value of y is pi over 12. All right. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.